Hello everyone. In this video, we will go through 15 sample questions and answer them in detail to help you prepare for the DP-100 Designing and Implementing a Data Science Solution on Azure exam. In case if you like to purchase the entire set of practice questions, use the link in the description below. Also, check out my YouTube channel. I have already covered the sample exam questions for other Azure certifications, and in case if you don't find them for any particular Azure certification, please leave a comment. I will create a video on that. So let's get started. For your ML experiments, you need to process CSV data files. Size of the file is about 10 gigabytes each. Your training script loads the ingested data to a pandas data frame object, but during the run, you get an out-of-memory error. So you decide to convert the files to a Parquet format and process it partially, that is, loading only the columns relevant from the modeling point of view. Does it solve the problem? First, let's understand how a Parquet format is different from a CSV format. CSV, a simple format used by many tools, is a default format for several data processing pipelines. However, it comes with a few drawbacks, many of which can be easily overcome by converting it to a columnar storage like Parquet. As you can see in the table here, the Parquet format offers several advantages in storage size and query runtime over the CSV format, which is really handy, especially in the cloud, since you're dealing with a huge volume of data. Coming back to the question, it is mentioned that the data is loaded into a pandas data frame object, and doing so you get an out-of-memory error. But loading a 10 gigabyte data file can easily occupy 10 times its size in a data frame. It is easy to see how you can quickly run out of memory in a data frame. Using a Parquet file, which stores data in a columnar format, you only load the relevant columns, so you cut down on the memory requirement. So using a Parquet format to process the files partially should solve the problem. Option A is the right choice. After successfully training your ML model and selecting the best run, you are about to deploy it as a web service to the production environment. Because you anticipate a massive amount of requests to be handled by the service, you choose AKS as a compute target. You use this script to deploy your model, and after running the deployment script, you receive an error. After a short investigation, you find that an important setting is missing from the inference configuration definition. You decide to add entry script as one of the parameters of the inference configuration object. Does it solve the problem? If you look at the definition of inference configuration object, one of the first things that's required to be defined is the entry script along with the environment definition. The entry script is missing in the inference configuration definition. Adding it should solve the problem. You are tasked to set up a machine learning environment for running experiments. While configuring the compute environment, your priority is to provision the necessary capacity, but also to keep cost as low as possible. Which of the following is not a way to optimize the cost? Option A is incorrect because using your own local environment for code development generates no extra cost, not even for longer execution times. Option C is incorrect because in a cloud environment, using the pay-as-you-go model, automatically launching and stopping computes is one of the best ways of preventing cost from exploding. Option D is incorrect too, because in the cloud environment, you can set up compute clusters which provide the necessary compute power while scaling up and down automatically according to the actual demand. Option B is the right answer, as AKS is recommended only for high-scale production environments, not the best way to keep your costs low. You have a real-time inference web service which you have just deployed to Azure Kubernetes service. During its run, some unexpected errors occur. You need to troubleshoot it quickly and cost-effectively. which is the quickest and the cheapest option you can use. Option A is the right answer because using a local web service makes it easier to troubleshoot and debug problems. If you face problems with your model deployed to ACI or AKS, try to deploy it as a local web service and then troubleshoot the runtime issues by making changes to the scoring file that's referenced in the inference configuration. This can only be done locally. Option B is incorrect because Azure Container Instances is designed to be used for low-scale production deployments. If you get some errors, it is highly recommended to debug locally before deploying the web service to ACI. Option C is incorrect because while an Azure Compute instance might be a good target platform for debugging, using a local containerized environment is even better. Option D is incorrect because Azure Kubernetes Service is to be used for high-scale production deployments. Being a powerful runtime environment, it is far too expensive for testing and debugging. You develop an ML pipeline using Python SDK and you need to separate the data for training and testing the trained model. You get a code snippet from your less experienced teammate, which is of great help if it works, but you have to check if it does the job. By its description, the script loads data from the default data store and separates 70% of the observations for training and the rest of them for testing by using the scikit-learn package in a reproducible way. After reviewing the code, do you think it does its job as described? Well, first, this code gets the run context and loads the diabetes data into the pandas data frame. And it separates the x and y values with diabetic values in the target y and the rest of the values as the predictors x. Finally, it splits both x and y values into train and test dataset with the train test split method with 30% of the data allocated for the test set and the remaining for the training set. Well, the scenario here is very similar to the earlier question, so just revisit the second question once to know more about the details. The only difference is that to resolve the deployment error, you decide to add this line of code while creating the inference configuration object. Will this solve the problem? Well, as already discussed, the inference configuration object is used to combine two important things: the entry script and the environment definition. The entry script defines the path to the file that contains the ML code to execute. Since it is still missing in the script, only adding a record for the entry script will fix the error. In addition to that, the cluster name parameter is important for the deployment, but it is part of the compute target configuration, which in this case is my production cluster. So option B is the right answer. While setting up your machine learning experiments, you need to ensure that the trained models will be appropriately scored with validation data. Azure ML SDK provides several methods to specify in your scripts on how to determine the data to be used for validation. Which of the following is not a valid set of parameters for specifying validation methods? Select any two. Well, in all cases, to determine the data for validation, you need primary metric and training data. Option A provides valid set of parameters because if only training data is provided, Azure Machine Learning applies default splitting rules to determine validation data. So choice A is incorrect. For option B, a primary metric and both training and validation data are provided. And these can be used directly, so no automatic splitting is required. So it is incorrect. Option C does not provide training data which is required, so they are not a valid set of parameters. Option D is incorrect because when only training data is provided with validation set size set manually, this value will be used to split data into training and validation sets. Option E is another correct choice because it is redundant to have both validation data and validation set size. Only training data with validation set size is sufficient. You are building an ML model for which you want to find the optimal parameter setting which results in the best performing model. You decide to use the hyperparameter tuning feature of Azure ML. That is, you use hyperdrive in your experiments. Using hyperdrive requires some specific conditions your script must fulfill. Which components or settings are specific only for the hyperdrive experiments? First, hyperdrive is nothing but a package which contains modules and classes that lets you automate the hyperparameter tuning. That is, it searches for the model parameters in the search space you define so as to optimize the primary metric. Basically, the hyperdrive serves to launch multiple child runs, each with a different hyperparameter combination. So if a script argument is added for each parameter to be adjusted, hyperdrive can evaluate the runs and select the best performing combination. Therefore, adding a script argument for hyperparameters is one of the right answers. That eliminates options A and D. In addition to that, the script config and script run config are common configuration objects used by any ML experiment. They are not specific for hyperdrive experiments. And similarly, the training and test validation datasets are fundamental components of any machine learning experiment. Arguing on similar lines, the estimators are commonly used in any experiment, so option B is incorrect too. That leaves us only with option C, where it is a requirement that the training script for your model must log the primary metric during model training so that hyperdrive can access it for hyperparameter tuning. You run experiments with Azure Auto ML service and you need to configure the model's hyperparameters. You define the sampling space for two parameters and use AutoML to use a sampling method that picks samples based on the result of previous runs in order to improve the performance in the primary metric. Does this script fulfill your requirement? Well, there are three parameter sampling methods that you can use to find hyperparameters in Azure Machine Learning. They are random sampling, grid sampling, and Bayesian sampling. Of these, only the Bayesian sampling method correctly matches the description given in the question. That is, it picks samples based on how previous samples have performed so as to optimize the primary metric. So option A is the right answer. As part of an ML team, your task is to build a workflow to chain several steps of the ML process in order to automate a series of tasks and to allow automation and reuse. You use the pipeline feature of the Azure ML stack. You have planned the main steps in the pipeline and now you are about to optimize how to organize your files around your pipeline. Which two of the following options are true and should be used as a best practice in pipeline design? Option A is incorrect because if the scripts of all the steps of a pipeline are in a single directory, every time the content of the directory changes, it will force all the steps to rerun. So we are not reusing any of the previous step results. Option B is the right answer because placing the files for each step in a separate folder ensures that if the files of any step changes, only the output data for that step is regenerated while all the others remain unchanged and reusable. Next, you need to know that changes in any files in the step's source directory trigger a re-upload of the snapshot. So maintaining scripts in separate folders for each step helps reduce the size of the snapshot because only the specific folder is snapshotted. Based on this knowledge, you can easily see why option D is correct and option C is incorrect. Option E is not a best practice in pipeline design because if you change the default setting for allowing reuse and set it to false, the results of the previous step of a run are not reused. In order to save time and resources, changing the default behavior is only recommended if there is a specific reason as to why the results must be regenerated. You have deployed your real-time inference web service on the Azure Container Instance environment. You need to ensure that only the customer services that have the appropriate authentication credentials can have access to it. Which authentication method can you use? Refer to this documentation page which talks about the authentication methods that you can use for deployed models on Azure Machine Learning. If the web service is deployed on Azure Kubernetes service, you can use either a key or token authentication. Whereas for Azure Container instances, only key-based authentication is available. So option B is the right choice. Options A and C are incorrect because Azure Machine Learning provides only two ways to control access to web services: keys and tokens. User ID and password is not applicable here. You work for a company which is operating a web shop. All transactions flowing through the site are directed to a real-time inferencing web service to identify potentially risky transactions. One of the transactions is classified by the model as suspicious, and before taking any action, you are tasked with to investigate which features make the model think so. You decide to use Mimic Explainer to help you understand why this specific transaction is classified as suspicious. Does it serve your purpose? The model explainers supported by Azure can be categorized into the following: the tabular explainers, the mimic explainers, and the permutation feature importance explainers or PFI explainers. All three of them can be used for explaining the global importance of features, but only the tabular and the mimic explainers are applicable if you need to interpret local importance. So mimic explainer will serve your purpose. For running your ML experiments, you want to create a separate Python script for configuring and running the experiment and store it in a folder for future use. While writing the script, there are a list of key steps you have to include in a specific order. Which of the following options reflect the right order of the required steps within the script? The very first step is a connection to the Azure Machine Learning workspace, so that eliminates option B. Then the run.getContext method is used for running the script, which retrieves the current service context. The third step is the script run config method that contains the configuration information needed to submit a run in Azure ML, including the script, the compute target, and other details for the script to be run. Finally, you submit the experiment with the experiment.submit method. So option C is the right answer. For your machine learning experiments, you are going to use the scikit-learn framework. You want to keep your Python code that defines the run configuration as simple and compact as possible. What is the best way to achieve this goal? Of all the answers, option B is the right answer because the simplest way to define the run configuration for the learning script built on a given ML framework, like for example scikit-learn, is to use the framework-specific estimators, in this case sklearn estimator. Option A is incorrect because while this solution can be used to set the run configuration, in the case of scikit-learn framework, using the pre-configured sklearn estimator is the best choice. Option C is incorrect too for the same reason. Option D is incorrect because the specific machine learning packages like scikit-learn, PyTorch, etc. are not contained in the base configuration. If you need scikit-learn, you have to add it to your run configuration either via script run config or via an estimator. For your ML experiments, you need to process CSV data files. Size of your file is about 2 GB each. Your training script loads the ingested data to a pandas data frame object. During the first run, you get an out-of-memory error. You decide to double the size of the compute memory, which is 16 GB currently. Does it solve the problem? As we discussed in the first question, the data in a CSV file can expand as much as 10 times when loaded into a data frame in memory. So it is recommended to set the size of the memory to at least 2 times the size of the input data. Doubling the memory size gives you a total of 32 GB of memory, which can conveniently fit a file with an expanded size of up to 20 gigabytes. So it does solve the problem. Once you are done, submit the test and you can verify your performance from the result. Also, you get the performance report domain-wise, so you can analyze the questions for any particular domain and you will see all the questions related to that domain, their correct answers and explanation for each question, and also links to the Microsoft documentation in case you like to learn the concept in depth. So if you are preparing for the DP-100, designing and implementing a data science solution on Azure exam, check the description for the link to the entire practice test that cover the length and breadth of all the objectives in the exam. Also check out my YouTube channel. I have already covered the sample exam questions for other Azure certifications, and in case if you don't find them for any particular Azure certification, please leave a comment. I will create a video on that. Thanks for watching my video.